When I first started teaching you about motion, I always ask you to visualize the three graphs: acceleration time graph, the speed time graph, and the distance time graph. And then at a later stage, I ask you to abandon speed and use velocity, because velocity is a lot more useful than speed. Now I'm going to ask you to abandon distance and replace it with displacement. Displacement. Okay. The reason is because displacement again is a lot more useful than distance. So let's look at this scenario here, where this is you here. You're going to throw a stone up in the air, and then it's going to reach its maximum height, and then it's going to fall back down to earth here. Okay, so suppose on the way up here, okay, it hasn't reached its maximum height yet. The distance traveled here is the same as the displacement. Okay, but let's say it reached its maximum height here, and then it starts to fall back down to earth. Let's say it's at this stage here. Now the distance here is the distance traveled, which is this. Okay, but the displacement is just the actual distance away from the original. So the displacement is this length here, as opposed to the distance here. The distance is all the way up here, and well, there won't be a curve like this. It will be up here and straight down like that. But the thing is, when we're talking about displacement, it's actually the distance away from your reference point. This here is our reference point. I could have picked down here to be our reference point, but I just want to illustrate this by picking this as a reference point. So this level here is our reference point. So when you throw a stone up like this, and then it starts to go down, the displacement is this distance here, whereas the distance is going to be this plus the downwards distance here as well. So it's going to be this bit here times 2, and then plus this. Well, anyway, let's say you throw the stone up, it reaches its maximum height, goes back down, and it's here now. Okay, so here the distance would be this. The distance traveled would be here. Okay, but the displacement is just this bit here. Okay, so the displacement is just the actual distance away from the reference point. This is our reference point. I defined this reference point here, meaning that I could have chosen anywhere, but I chose this point here. Okay, well, displacement is a lot more useful than distance. So from now on, get rid of displacement, get rid of distance and use displacement. So our three graphs will be this: acceleration, time, and then normally it's speed and time, but we're gonna get rid of speed and use velocity, time, and now we're gonna get rid of distance and we're gonna use displacement. Okay, still D. So acceleration, velocity, and displacement. The reason for that is well, again, if you shoot a cannonball up, it's going to go like this. The displacement here would be this distance here. The distance would be this here. Well, most of the time we don't care about how far this cannonball has traveled. We just care about the height, because the height here is so much more useful than the actual distance here. Because let's say soon I'm going to ask you to calculate. Well, we're going to shoot a cannonball at an angle, so it will travel like this. You see, now we defined our reference point to be this level here. Don't worry if you don't understand this much. This bit here. Well, in real life, we only care about how high above ground this cannonball is at any given time. So we don't care about the actual up and down here. We don't care about this bit here. This is why we only care about displacement. Suppose you want to know where the cannonball is right at this point here. You don't care about it going all the way up here and then down here. you don't really care about this bit. You only care about the actual the actual distance the actual distance from here to here. You only care about the displacement, or if you want to find out the height here, well, in this case, the distance and the displacement will be the same here. But suppose you're here, the the you're interested in the displacement here. You don't care about the distance. Okay, the distance is this distance here, all the way up and down, whereas displacement's only here. Just remember that this displacement is a lot more useful than distance, and you understand why as time goes on. But just for the time being, just accept that displacement is more important than distance. So get rid of distance and let's just use displacement for now on. Okay.